So today we are going to start on Section 1, Lesson 4 of The Making of a Scientist. Section 1 has 5 lessons in it. Tomorrow you will do Lesson 5. You will have access to a study guide, and then on Friday you will need to take your Section 1 test. Okay, now that is a big 100-point test. If you do not do anything else for me, I need you to do that test, okay? So, what we're going to do today is we're actually not going to go back into the making of a scientist. We are going to learn about the process of scientific inquiry by reading Scientific Thinking. And we're not going to practice expanding a kernel sentence. I decided we're not going to do the writing revolution this year. So, get your scientific thinking article out. I was part of the papers that we brought to you. And while you're doing that, let's go over this culminating writing task again. How does the process of scientific inquiry lead to the development of advanced technology? How does asking those scientific questions lead to better technology? And this is another article that we're going to read on the scientific inquiry process. So before we start reading, take a look at that article. Is that text literary, fiction, which means fake, or is it informational, nonfiction, which means real? It is nonfiction, which means it's real. It's another article that we're going to read. Now, unlike The Making of a Scientist, we aren't going to number these paragraphs because there's a lot of bullets in it, which makes that kind of hard to do. So while we are reading, I want you to think about how this article is the same and different from The Making of a Scientist, okay? So, scientific thinking. According to Think Science, people engage in scientific thinking every day. The article suggests we think like scientists when we wonder. We think like scientists when we see something surprising and try to figure out how it happened. Or we seek out more evidence, which can help us prove or disprove our original thoughts about how something may have happened. We also think like scientists when we come up with a new explanation for a mystery. For example, perhaps you see a magician make his make his assistant disappear from a box and wonder if the trick involves a trapdoor. So you look for a joint in the floor beneath the box. When you don't see one, you develop a new explanation, such as perhaps the trick used a mirror to reflect an image of an empty wall. How can you think like a scientist? Thinking like a scientist. I don't know why it's not letting me highlight this stuff. Okay, anyway, the arrow will be at the paragraph that we're at. Thinking like a scientist requires having knowledge and engaging in a scientific process. Now, I can click on that read more link, but we're not going to. So we're going to skip down to right here where it says knowledge. Scientists learn about the facts, laws, theories, and ideas which describe the world around us and how it works. Scientists study this information to learn more about what they are observing and to further explore and challenge what other scientists have explored before. Process. Scientists also study the physical and natural world through observation and experiments. Scientists engage in a process of discovery or inquiry to refine their thinking and develop an understanding of the world around them. They observe the physical and natural world, think about why things exist, and act the way they do, develop an idea or hypothesis to explain their thoughts, engage in various experiments to test their original thoughts, and make connections and draw conclusions about the evidence they uncover. What is science? So, what is scientific inquiry? Scientific inquiry is the process through which scientists understand the world around them. The process involves asking questions, engaging in a process to answer those questions, like an experiment, drawing conclusions about the resulting information or data, developing an explanation based on those conclusions, and communicating and defending the explanation. Scientific terminology. Data is facts, information, or statistics collected and used to analyze or determine something. Evidence are facts or information which show what that something exists or an idea or belief is true or valid. A hypothesis is a testable statement or idea. For example, eating chocolate daily does not affect a person's weight. A law is a widely accepted hypothesis or a statement about the physical or natural world, which is observed through repeated experiments. Scientific law can predict the outcome of certain experiments. They always work when the same conditions are applied. For example, if you drop an apple from a building in the same way under the same conditions, the laws of gravity will apply and the result will likely be the same each time. So, a scientific law does not mean like if you break it, you're going to go to jail. It means that it's always going to happen. If you drop an apple on Earth, it's never going to just magically fly back up into the air. It's always going to drop towards the ground. Theory, a general principle or body of principles that explain the physical or natural world. Theories come from hypotheses and laws that have been tested many times under different conditions with accurate results. When new knowledge is observed, theories can be revised to explain the new information. So, what is the difference between a theory and a law? Because they sound very similar. Well, a theory is kind of like a baby law. It is something that scientists really do believe is true, but there's no way for them to really test it. Valid, a reasonable or acceptable result. So, reasonable or acceptable, meaning that if your results match your hypothesis, then it's considered valid. All right. So, let's take a look at this statement from the article. Scientists also study the physical and natural world through observation and experiment. Scientists engage in a process of discovery or inquiry to refine their thinking and develop an understanding of the world around them. So, what exactly is a process? Process is it's an experiment. It's a way to test out your observations to see if what you're observing is true or if it's because of something else. So before you go and you do your Google form, I said that you were going to need to compare the making of a scientist to scientific thinking. You need to think of one way that they are the same and one way they are different. Now, it's super easy to think of a way that they are different. So go ahead and start thinking of some ideas right now. You might say that one is an autobiography and one is just an informational article. One of them tells stories about somebody's childhood while the other is giving you just facts. That's the most obvious difference. Now, the similarities between the two of them might be a little bit harder to see. So, Richard Feynman's father, in The Making of a Scientist, he taught him to make those observations of the world around him. And what was scientific thinking talking about? How we can test the observations that we make about the world around us. So both articles have to do with making observations about the world around us and then testing out those observations. So go ahead and go to the Google form and get started on your work for today. Make sure you're hitting the submit button when you're done so that way I can grade it because I will start grading your work on Friday. All right. I miss you, buddy. I'll see you soon.